Hey students, in this video we're going to be talking about polynomial and rational inequalities. The types of inequalities that we're going to see are less than, greater than, less than or equal to, greater than or equal to. And how we're going to be solving these inequalities is we're going to create and interpret a sign chart. A sign chart is going to help us be able to determine when a graph is positive, when a function is positive, negative, zero, and undefined. Sign charts are an organization tool used to tell when a function is positive, negative, undefined, and zero. To create a sign chart without the aid of a graph, a function must be in factored form. So really important that if ever you have a function that's not in factored form, you will have to factor in order to create a sign chart. We're going to be talking about functions that are already in factored form today. So let's take a look at some examples. I have an example of this function, and we're going to create a sign chart for the function x plus 3 times x minus 9 squared times x plus 1 cubed. So here this function is already in factored form, and then we're going to use this factored form to answer these inequalities. Where is the function greater than 0? Where is the function less than 0? Where is the function greater than or equal to 0? And where is the function less than or equal to 0? So the first thing that I'm going to do is I'm going to create a little bit of space so that I can make a sign chart. The sign chart is an exploration of the x-axis and the function. So I'm going to draw an x-axis, and I'm going to start to identify the way that this function behaves in relation to the x-axis. So in this polynomial, I can find the x-intercepts by setting all the factors equal to 0. So my first factor, my second factor, and my third. I'm going to solve all of these and find all of my x-intercepts on the graph. Once I have my x-intercepts, I'm going to place them on the x-axis that I've drawn. It doesn't have to be a perfect distribution, but -3 and -1, they do need to be in order. So -3, -1, and 9. These are all of my x-intercepts. And because these are x-intercepts, this function is where all these values is where the function has a y value of 0. So I'm going to put a little 0 over top of them so that I know that at -3, at -1, and at +9, the function's values are 0. So now what I want to do is to figure out, well, what about in between or around these values? I'm going to use what's called a test point in the interval that is being broken up by these x-intercepts. So the first interval that I'm going to explore is the interval from -infinity to -3. This interval, I can use any number in this interval as a test point of the function. So let's say, for instance, I want to use the value -5. -5 is my test point, and to test this, I'm going to plug it into the function. By plugging this into the function, I'm going to be able to determine whether the sign of this is positive, negative, or if the value is undefined. So I'm going to first plug in my 5 to the function. Because what we're creating is a sign chart, I don't actually care about the value of f of -5. I care about the sign of f of -5. So I'm going to determine the sign of this overall value by finding the sign of my each individual factors. The first factor is -5 plus 3. -5 plus 3 will have a negative sign. Okay. Then this is going to get multiplied by the next factor. The next factor is -5 minus 9 squared. -5 minus 9 is a negative number, but then when I square a negative number, negative times a negative is going to be a positive number. So my second factor is positive. And then my third factor that's being multiplied to create this polynomial is -5 plus 1 cubed. -5 plus 1 is -4. So it's a negative number. And when I cube a negative number, that means I'm multiplying it by itself 3 times. So I'm doing a negative times a negative times a negative. And if I multiply two negatives, that would make it a positive. And then when I multiply a third negative, it'll make it back to a negative. So my third factor is a negative. So what I'm actually multiplying is a negative number times a positive number times a negative number. To find the overall sign, a negative times a positive is a negative, and then times another negative would make my overall sign positive. So the sign of f of negative 5 is a positive sign. Okay, again, notice I don't actually care about the value of f of negative 5. I could find that value, but it's not required. A lot of this is going to require a lot of mental math where we're finding the sign of this value. Okay, let's do the next section. The next interval that I'm going to be concerned with is the interval from negative 3 to 1. Negative 3 to 1, I can use the value negative 2. So I'm going to find f of negative 2's sign. Okay, talking through my signs here, negative 2 plus 3 is a positive number times negative 2 minus 9 is negative, but when that's squared, it will become positive. And negative 2 plus 1 is negative. A negative number cubed is a negative number. So this is a positive factor times a positive factor times a negative factor. This would result in a negative sign. So f of negative 2 is negative. That means that whole section is negative. Okay, I'm going to do the next section as well, from negative 1 to 9. Negative 1 to 9, the best number to use here is the number test point 0. So I'm going to find f of 0. And then my last section, I'm going to find f of 10. So I'll do f of 0 for the section, the interval from negative 1 to 9, and f of 10 for the interval from 9 to infinity. I'm going to need a little bit more space. See if you can pause the video and determine the sign of f of 0 and f of 10 on your own. Okay, now that I have my sign chart, I'm going to use my sign chart to answer these questions. Where's the function greater than 0? Where the function is greater than 0 in all the intervals where the function is positive. So I'm going to write down all of my intervals of space where the graph is positive. From negative infinity to negative 3, from negative 1 to 9, and from 9 to infinity. Where is the function less than 0? Well, we're talking about the interval of space where the graph is negative. So we're talking about the interval from negative 3 to negative 1. Where is the function greater than or equal to 0? Well, this is going to be the same exact intervals that I use when it's greater than 0. But now because it's equal to, I'm going to include the values that are 0. So I can use a bracket for everywhere that x is also equal to 0. So from negative infinity to negative 3, but negative 3, the value is 0, so it is included. From negative 1, which the value is 0, so I'm going to include that. 9 is also included, so I'm going to keep going, and I'm going to go all the way to infinity. And last but not least, where is it less than or equal to 0? I'm going to include the 0 points, but where the function is negative and 0 is negative 3 to negative 1, and those points are included because they are 0 there. Okay, that's it for this example. Let's go take a look at another one. Okay, my next example is to create a sign chart for this rational function, and then again, we're going to use that sign chart to answer when is the function greater than 0, less than 0, greater than or equal to 0, or less than or equal to 0. I'm going to go ahead and get some space and set up my sign chart. Okay, for rational functions, the important things that I need to find are wholes, vertical asymptotes, and x-intercepts. See if you can remember what we know about rational functions and see if you can find the wholes, vertical asymptotes, and x-intercepts of this graph. Okay, I found vertical asymptotes at negative 4 and 1. I found x-intercepts at 5/2 and 7. So it is important to understand the difference between a vertical asymptote and an x-intercept here. Vertical asymptotes are undefined values in the graph, and x-intercepts are zeros. Okay, now we're going to set up our test points, and then I'm probably going to do most of that work off screen. So we're going to find the signs in the following areas. The first sign that we'll find is below -4, so we can use a value like -5. We're going to use, the next section is between -4 and +1, so we can use an x value of 0 as our test point. Between 1 and 5/2, we can use the value 2. Between 5/2 and 7, we can use the value 4. And greater than 7, we can use the value 10. Okay, so now we're going to find all of our functions values. And again, we're mostly focused on the sign for all of these sections. So we're using our test points to find the function sign at -5, f of 0, f of 2, f of 4, and f of 10. Okay, I'll do one of these with you guys, and then I'm going to let you guys try the remaining signs on your own. I'm going to write it all out, but it is important to know that a lot of this is just mental math. So if you can do the signs in your head, that's great. So I'm plugging -5 in for everywhere that I have an x in my equation, and I'm just interpreting the signs of each factor. So the first factor is 2 times -5 minus 5, so that's negative, but then I square that factor, so it's positive. -5 minus 7 is a negative number, and then I'm going to divide this by -5 plus 4, which is a negative number, times -5 minus 1, also a negative number. So my numerator is a positive number times a negative, which is negative. My denominator is negative times negative, which is a positive number. So my overall sign is going to be a negative divided by a positive, which is a negative sign. So again, all I did was just kind of plug in the number in for x, and I thought about, well, what's the overall sign going to be? You're going to have 4 factors, 2 in the numerator, 2 in the denominator, and then you can simplify the signs from there. See if you can pause the video and do the signs of 0, 2, 4, and 10 on your own. Okay, pause the video to check your work. The signs that I got for each section from -infinity to -4 was a negative number. From -4 to 1, I got a positive. From 1 to 5/2, I got a negative. From 5/2 to 7, I got a negative. And from 7 to infinity, I got a positive. So now that we have this sign chart, we're going to answer these questions about the sign chart. So when is the function greater than 0? Well, the function is greater than 0 everywhere that the graph is positive. So -4 to 1 and 7 to infinity. Where is it less than 0 is everywhere the function is negative. Okay, I got -infinity to -4. Union 1 to 5/2, and then 5/2 to 7. Again, just talking about the sections where the graph is negative or less than 0. And then when it is greater than or equal to 0, it's going to be the same as when it is greater than 0, but now we're going to include the values when it equals 0. Important to understand, we'll never include the undefined values. So -4 is undefined, so we're not going to include that value. 1 is undefined, so I'm still going to use a parentheses to not include that value. But at 7, the function's value is 0, so I'm going to use a bracket to include 7 to infinity. And then when it's less than or equal to 0, I'm going to do the same intervals as when it is less than 0, but I'm going to use a bracket everywhere that the function is 0, so at 5/2 and 7. So I said from negative infinity to -4, where -4 is not included. And then I said from 1 all the way to 7, I included 5/2, and I also included 7 using a bracket because, again, it can equal 0 here. Okay, let's take a look. And the next example, I want you to try it totally on your own. Okay, here's another example. I want you to pause the video and try this one on your own from top to bottom. I'm going to just cut straight to the answer. So if you want to give this a try, pause the video. Okay, take a second and pause the video to check your work. My important values that I found are -6 was an x-intercept, 0 was an x-intercept, and 3 was a vertical asymptote. I found that the graph was negative, then positive, negative, and then negative, and these are the test points that I used. And then I used this information to determine when the function was greater than 0, less than 0, greater than or equal to 0, meaning I can include the zeros, and less than or equal to 0, which means I could include the zeros, but make sure you still never include the undefined values because that function's not defined on the function. Okay, I want to take a second and look at the graph of this function to highlight what we're looking at, what this sign chart is actually saying about the graph. Okay, I have the graph of this function pulled up, and I'm just going to highlight really quickly each individual section. So when x is less than 6, we're describing where the graph is negative or below the x-axis. Between -6 and 0, that function pops up just a little bit above the x-axis, which is why we denoted that section with a positive sign on our sign chart. Between 0 and 3, the graph is negative, and it's approaching a vertical asymptote in the graph. And between 3 and infinity, the graph is still negative. It is this kind of like U-shaped shape down at the bottom. So again, this sign chart is showing where the graph is positive, negative, and 0, and undefined. So it's just kind of showing where is the graph above the x-axis, below the x-axis, when it is on the x-axis, and when the value is undefined as part of the function. Okay, for our very last problem, we're going to create a sign chart to find when this equation is less than or equal to 0. So instead of finding all ones where it's greater than 0, less than 0, greater than or equal to, less than or equal to, we're only interested in the less than or equal to part. So I'm going to go ahead and start to set up my sign chart, and I'm going to walk through this one because this one has a few interesting things that happen. Okay, there are no holes in this graph. The x-intercept is going to come from that square root function in the numerator. And my vertical asymptotes are going to come from my two factors in the denominator. One of them is inside an absolute value, and that's going to affect our plug-in values, but not how we find the vertical asymptote. Like before, I'm going to set up my sections and pick my test values in each section. The first one I'll do with you because this is where the interesting thing happens. If I take this -10 and I plug it inside of the square root, that's going to give me a -10 plus 8, which is a negative inside the square root. We know that that can't happen. It's an imaginary number. So all of these values are imaginary, meaning in my graph, we just use undefined for that whole section. Okay, that's the only one that's really strange. See if you can pause the video and find the signs of your remaining sections. Okay, I got the first section was undefined imaginary. The second one, I did f of 0, which it was a number in between -8 and 3, and I got that that section was negative. F of 4 was also a negative value, so the whole section from 3 to 5 is negative, and then I had originally picked 5, but that was wrong. I needed something greater than 5 to check that region, so I found F of 6, and I found that to be a positive value. Okay, so the question that I'm being asked is when is this function greater than or equal, or sorry, less than or equal to 0? So the only thing I care about are the sections where it is negative, and it can equal 0, so I can use brackets where 0 is included. included. So I'm going to go from -8, including -8, up to 3. I can't include 3 because it's an undefined value. And then I'm going to go from 3 to 5, using parentheses on both of those because both 3 and 5 are undefined values on the graph. Okay, that's it for this video, and we'll do more practice with this in class tomorrow.